Okay, let's do another confidence interval example here. This says direct mail advertisers send solicitations to thousands of potential customers in the hope that some will buy some of the company's product. The response rate usually is quite low. Suppose a company wants to test the response to a new flyer and they send it to 1,000 people randomly selected. So that's actually, when they tell me who's randomly selected, they're giving me my N from their mailing list of over 200,000 people. This right here is my population size, and it's given, I'm trying to write a little arrow here for you, and it's given there so that you can help to verify your conditions. Then it says, let's make this clear, that's the letter N. Then it says they get 123 orders. So in this case, we're actually given our letter X. We don't have to compute it. We're just provided with the number of people who quote unquote said yes or are being measured as a success. Okay, let's keep reading. Check your conditions and for creating a confidence interval on the proportion of people who may buy something. So we saw before that the first condition is independence. I'm going to be abbreviating here, / randomization. And in this case, if we read back in the previous part of the problem, it says that we selected 1,000 people that were randomly selected, right? So I'm going to go ahead and quote that again. Randomly selected. So they are independent. That has been met. The second condition we check is success, failure. And this is actually less work than last time. Last time we had to actually multiply N times P to figure out what X was, but this time we're actually given the number of people who said yes. So here we know X is 123, which is in fact bigger than 10. Just need a sip of water, sorry. And then we try to find the number of people who said no, or what they refer to as failures. And to do that, we take 1,000 and subtract the people who said yes. We end up with 877, which is also bigger than or equal to 10. Okay, third condition, finally, the 10% condition. So this is what we're saying, is 1,000, the reason they gave us the 200,000 is because they want us to check this. Is 1,000 over 200,000 less than 10%? That's our question. And the answer here is absolutely. You can go ahead and put that into your calculator and convert it. It is less than 10%. It's okay, Dexter. Dex, come here. So now we have to create a 90% confidence interval for the percentage of people the company contacts who might buy something. I'm 100% going to go let him outside so he stops whining at me. Give me 1 second. I'm coming right back. I don't need you out, Jackie, because you'll bark at everybody. Okay, create a 90% confidence interval for the percentage of people the company contacts who might buy something. So remember that a confidence interval, in the way that we know them so far, are 1 prop z intervals, and we need to give the calculator x, n, and the confidence level. Our x is 123, our n is 1,000, and remember that the confidence level goes in as a decimal, and this is found under stat, arrowing right twice, and scrolling down to find option A. Once you do that, we end up with just 0.106. I don't know why I chose 3 decimal places when in the last video I told you I'd do 4. But this is the interval I recorded. And then in part C, it says to interpret it. So this is that statement we wrote before. It says like we are 90% confident. The true proportion, so this is the true proportion, if I can spell it, refers to the population proportion. So this says we are 90% confident the true proportion of, and then we want to make sure we phrase this right, people who may buy something because that's who we're talking about here. That's supposed to say something. Falls between, and then we want to be specific given our interval, 10.6% and 14%. Okay, so that is what our interval says. It says even though we've only selected a smaller sample, because we met our conditions, we can generalize about the population at hand. Then we try to answer the follow-up question. This is the reason why we actually make a confidence interval in the first place, to answer a follow-up question like this. The company must decide whether to now do a mass mailing. It will not be cost-effective unless it produces at least a 5% return. What does your confidence interval suggest? All right, well, let's interpret at least 5%. This is more than 5%, ideally, correct? I did not really compute that correctly. But what we really want in our interval is greater than 5%, if possible. So the way that we want to think about the answer to this is by looking at both the lower and upper bound of our interval. We are predicting a 10 to 14% return, which is well above 5%. So we can actually answer that in this particular question here. Our interval suggests returns between 10 and 14%. So the mailing is cost effective because both let's make sure we state this so we all understand it. The lower bound and upper bound are above 5%, which is what we mean by at least 5.